Hello guys, you might have heard about the Google keyboard or Gboard. Gboard is an statistical decoding based keyboard on mobile devices developed by Google. Decoding is necessary due to the error prone process of a fat finger touch input on small screens. The thing is that with this Gboard, Google changed the way we used to use these keyboards on our mobile devices, including phones and tablets. Gboard provides various error correction features, some active or automatic, and other require the user's further manual actions and selection to provide a smooth typing experience. Active key correction or KC and active auto correction, word completion, and next word prediction support the user to type the current word and next word by fixing user typos and providing multiple word candidates in the suggestion bar or inline. That is also called as Smart Compose. Post correction supports fixing errors in last one or more committed words. Also, the more passive spell checker and grammar checker supported by small size logistic regression and sequence to sequence models respectively detect the possible errors in committed sentences and mark them with red underlines. Users can fix the errors by tapping the incorrect words and commit the correct words from the displayed candidates. Now, there are two types of user experience limitations with the existing correction approaches. First, users still have to type relatively slowly and accurately to avoid making too many or too severe errors that the small on-device correction models such as KC, AC, and PC cannot handle due to their limited ability to model longer span context. Second issue is that users need to manually engage in the multi-step passive correction feature such as grammar checker and the spell checker to correct the committed words one after another. This is where this new research or methodology proofread feature comes into play, and I will show you their paper. So this proofread feature is to alleviate the pain points of fast typers by providing the sentence level and paragraph level error fixes with only one tap. Proofread falls into the area of grammatical error correction or GEC, which has a long history of research from rule based to statistical approaches to neural network models. The astonishing capabilities and abilities growth of LLMs offer a new opportunity to unlock the high quality sentence level grammar fixes. Google has presented the entire system to tune and serve the LLM models behind Proofread in this paper, and I will drop the link to it in video's description. The system consists of four parts. First is data generation, metric design, model tuning, and model serving. Firstly, data set is generated by a carefully designed error synthetic framework which integrates error frequently made on keyboard to simulate the user's input. Several further steps are conducted to ensure the data distribution is close to Gboard domain maximally. Secondly, several matrices are designed to measure the model from various dimensions. As the answers are always not unique, especially for longer example, the metric combined with the grammar error existence check and same meaning check based on LLMs are considered as the key metrics for comparing the model quality. Thirdly, inspired by Instruct GPT, supervised fine tuning or SFT followed by RLHF is adopted to obtain the LLM dedicated for proofread features. There is a lot of other detail which is scattered throughout this paper. Now, another thing you need to remember for this is that they have obtained a high quality model with cautiously synthetic data generation, multiple phase supervised tuning, and RLHF. Also, they have deployed the model to TPU version 5 in the cloud with highly optimized latency acquired by quantization, buckets, input segmentation, and speculative decoding. And that doesn't end there. For example, if you look at this figure, this is the whole synthetic pipeline and synthesis of model tuning. The upper half of this figure shows that the pipeline to generate the data set. So what they have done is they have initially sampled data from the web crawl data set, which is then processed by a GEC model to fix the grammar errors. Each item in the dataset consists of a source sentence with several possible reference sentences. Grammar errors are then synthesized into the source sentence to simulate user's input. Various kind of errors which frequently happen in the Gboard real scenarios, including, for example, if you type hello as HLLO or hello as HEELO, these sort of errors. So to align the data set with real use cases, the data with synthetic errors are then passed to the Gboard simulator to fix error by leveraging Gboard's built-in literal decoding KC and AC functions. Also, several heuristic rules were then applied to fix cases such as emoji, emoticons alignment, date time formatting, and URL patterns. And the last step is to filter the noise data by utilizing LLM with careful design instructions to avoid polluting the model. And there are a lot of dimensions which they have checked with it, um, which you can read in the paper. Also, the lower half of the figure which you see is about model tuning, and these are all the tuning steps which they have done, where they have done supervised fine tuning after choosing the checkpoint, and it contains hundreds of text rewriting tasks. And then there are a lot of other things they have done after supervised fine tuning. They have done reinforcement learning, and then data has been leveraged with heuristic rewards in their model tuning, and that includes global reward and direct reward. And afterwards they have gone with a lot of other steps around model serving. So all in all, a real interesting and new feature in the implemented in the Gboard, powered by a carefully refined LLM. And I think this work really demonstrates the significant potential of LLMs to enhance the user's typing experience by providing high quality sentence and paragraph level correction, especially on the mobile devices. So that's it, guys. I hope that you enjoyed it. Let me know what do you think about this transformative power of LLMs in the realm of user input experience. I think this is going to be really huge when it comes to at least Android devices in the future. Also, one thing I would highly speculate maybe that this is going to be a big part of Google Pixel phone. Plus, there is also some experimentation which I checked out in this paper, where they have played around with Palm 2 XS model, which is extra small model, and the benchmarking is really amazing. Over 85%, and the deployment of the model on TPU was also very successful. Anyway, so let me know what do you think about this. If you like the content, then please consider subscribing to the channel. And if you're already subscribed, then please do me a favor and share it among your network, as it helps a lot. Thanks for watching.